So there are many ways we could start this problem, but again, anything on the outside, that -4, I will leave for the end. And because these are both underneath the radical, I can multiply them first and make that the square root of 45. Now, if I do that, I now want to make a factor tree for 45. And so 3 goes into 45 15 times. But if you notice what happens when I do it in that process, which is perfectly fine to do, I still end up with my 3 and my 15. And I'm pointing that out that I don't have to multiply those. I can just make a factor tree from each of those, but combine them at the end, which I'll do in the next problem. But still moving along my square root of 45, I'm going to take 15 and split that into 3 and 5. And so that gives me a 3 on the outside and the square root of 5 left over. Now I have to bring down my -4 and multiply that on the outside, giving me -12 square root of 5. So in the next problem, I could multiply 36 and 18 like I did in the previous problem, but remember that if I do that, I'm just going to split it into two numbers, which could be 36 and 18. So an easier way would be to simply do my factor tree from these terms, realizing that I could pair up numbers, and when I get down to my prime factors, I can make pairs using either term. So I can split 18 into 2 and 9, and 9 into 3 and 3, and now I am looking for pairs. I have a 2 on the outside. I have a 3 on the outside. I have another 3 on the outside. And that guy is left over. And so 2 times 3 is 6, and 6 times 3 is 18. And so I get 18 square root of 2. Now again, that's one way you could do it. You may have noticed that that is a perfect square and just simply written that as 6 to start off with, which would be another good way to do the problem. Either way, our answer should be the same at 18 square root of 2.